Hello everyone, we are TEAM-19. We are doing a presentation for our project for the subjects SER-502. It's called Pulsar. I'm Rishika Sardana.
Hi, I'm Janvi Gona.
Hi, I'm Bhavan Kumar Chinwada.
Hey, hi, this is Ritik Zamri.
Okay. So yeah, this is what we'll be covering in our presentation. So moving on to the introduction. So Pulsar is basically a custom interpreted programming language that we have developed from scratch. It is designed to be a simple, dynamic, and really easy to use, especially for learning and experimenting. We took inspiration from languages like Python and Java, and we've implemented the entire language using SWI Prolog. So moving on to the project objective. The main goal of our project was to basically create a lightweight and expressive programming language that supports essential programming constructs. And what we wanted to do was learn how programming languages are built from the ground up and use Prolog's DCG to build a lexer and parser. We also wanted to design and implement a working interpreter. And finally, we wanted to allow users to write and run basic programs with variables, loops, conditionals, and expressions. Moving on to the language description. So Pulsar supports basic data types such as integers, booleans, and strings. It also includes arithmetic operators like addition, subtraction, multiplication, and division. We can also use comparison operators like equal, greater than, and not equal to. We've also added logical operators like and, or, and not. And for control flow, Pulsar supports both while and for loops, as well as if else, and ternary conditionals. And just like Python, Pulsar is dynamically typed. For the tools and technologies used, we have used basically the SWI Prolog as our core development tool. The lexer and parser were both written using definite clause grammar, that is DCG, and we've built a custom interpreter to execute the parsed code. Pulsar is compatible with both Windows and Mac OS, so it should be easy to run on most systems. Moving on to the process flow for Pulsar. So a user will basically write a code in a .pls file, and the lexer basically processes the text and then passes it to the parser, which is defined using DCG. The parser will then produce a parse tree, which is then executed by the interpreter, and then the output is printed to the console. So this is the entire flow that is handled through Prolog. Now, Janvi will continue.
Moving on to program structure. So we have 4 modules: lexer, parser, interpreter, and driver. So what lexer does is basically converts the input, which is source code, into a list of tokens. And what parser does is it takes the input as tokens and then builds a parse tree, which would then be passed to the interpreter. Interpreter takes on the parse tree, executes it, and produces an output. And driver file is basically to coordinate the end-to-end execution of all these modules. Moving on to lexer, like I was saying before, it converts source code into a list of meaningful tokens. Key features, we have implemented our tokenize. This is the entry point. It uses DCG for pattern matching, and it ignores white space and comments, which supports both single and multi-line comments. And it recognizes numbers, identifiers, keywords, strings, and operators. This is the example token which can take numbers, keywords, or operators. So for example, if you see there's an expression of x is 5, it will identify each one of it, like if and open parentheses, each one of them as individual tokens, and ignores the comments and white spaces. And then these tokens are then passed to the parser. I'll quickly show the code version of lexer. Yeah, so the Pulsar lexer is, we have defined this module as a Prolog module, and we have exposed this predicate tokenize. And this is the entry point for the tokenizer, which takes a list of characters as an input and produces tokens as an output. And these are the token sequences, which whenever like white space or comment is encountered, it just skips and it starts going in terms of like executing tokens one by one recursively. And these are the token definitions of which our language supports, which has numbers, keywords, strings, identifiers, and operators. So for keywords, identifiers, and numbers, we have separate rules as well. Like for example, for identifiers, we put it like it has to start with a alphabet, and then it can have any number of alphanumerics. And similarly, we have a comments section where we support both single line and multi-line comments. Over to Bhavan.
Okay. Let me explain you the grammar of our programming language. So here I have added snapshot of it. And we have written this grammar in EBNF to define our rules of our programming language. And we use the same rules and implemented using the DCG in Prolog to implement our parser. Now let me explain you quickly what a parser is and what it does. So the main purpose of our parser is to take the list of tokens generated by the lexer and then turn them into a structured parse tree. And this acts as a bridge between our grammar and execution. And in our parser, our top rule is program by tree, and that's where the parsing starts. It tells our parser to begin looking for a sequence of valid statements. And also, as mentioned in the grammar, we support all these statements and expressions and scoping syntax. And all this I'll be showing you clearly in the parser file. And this is a sample Pulsar program. And if we give this input into our program, it will generate a parse tree. And this is as an intermediate format, and this is how it looks like. Let me just switch to the code and explain you clearly. Our Pulsar program is just a list of statements, which means it has a lines of codes, and that says to do something like either assigning values, printing, using loops, or writing conditions. And we also support writing comments to explain our code. And there will be single line comments and multiple line comments, but they won't be coming into our parser, as they will be completely ignored while creating a list of tokens by the lexer. And so this one is the starting point, as I mentioned in the presentation. And let's just jump into the different types of statements. The first one is assignment statement. So here we just set a value to the variable. And the next one is print statement. We just print whatever we want and show that in our command line. And the next one we have is if block. So this is followed by a else if block and then else block. So these are optional. So if there is any, so we have written them here. This is the block of code for both of them. And we also support while loop and for loop. So the while loops keep running until the condition is true. And when it comes to the for loop, just as in many common languages, it starts with an initialization condition and then update it. And now we have expressions. So we can do a simple math like addition, subtraction, multiplication, and division. And we also support logical operators like and, or, and not. And we have ternary condition. And we also have comparison operators like less than, greater than, double equal to, and not equal to. And for values, we support numbers, which is mainly integers, all the positive integers, and strings, which are in double quotes, and booleans, which is either true or false. And now coming to the finally variables and identifiers. So as long as they start with a letter or an underscore, they can be made up of any letters, numbers, or underscore. And that is all about our parser. And over to John.
Yeah, moving on to interpreter. So the purpose of this is it executes the program by evaluating statements and expressions. So key components of it are like execute program, which is the entry point, and it starts with an empty environment. And we have statement evaluation, where we have variable assignments, print statements, conditional logics, and loop constructs. And then we have expression evaluation, which deals with arithmetic, logical, relational, and ternary expressions are supported. So this is basically the sample output for an input. Quickly moving on to the code. This is the code for interpreter, where we have the Pulsar interpreter module. We have defined it. And this is the entry point in the program, which starts with an empty environment. So basically, environment is like a key value store for variables. And then we have statement evaluation section, where each statement gets evaluated one by one recursively. And as the evaluation keeps happening, the environment variables keep getting updated. So this is the assignment section. And in assignment, basically what we do is we evaluate the right side expression and bind it to a variable. And in print statements, you evaluate and output the value of the statement. And then this is the block for if, elif, and else. And then we have the similar implementation for while and for as well, the control flows. And then we have expression evaluation, where each node again gets recursively implemented one by one. And this expression evaluation handles ternary flows, Boolean, relational, expressions, and arithmetic. And yeah, so basically this takes the input from parse tree, which is the output of the parse tree. This takes parse tree as an input and then produces an output. So how an input can be processed by all these files and get an output, Ritik is going to explain now. So over to Ritik.
Okay, so let's start. So this is our language called Pulsar, which is denominated by the extension .pls. So we'll start from setup to output. Basically, what our language does is takes a data file and convert it to a list of tokens, and the tokens are then evaluated through the AST tree, and then we got output. To basically load this programming dependency in your system, you need some prerequisites to run this language in your systems. The first is to have the Swift in SWR Prolog version in your computer. You can check, do you have any? Or if you don't have this dependency on your system, you might get it through the Mac OS, Linux, and Windows documentation, which is mentioned here. And let's move on to setup of the project. So we have to clone the dependencies from the GitHub. So we'll just go to GitHub and clone the system. So we have cloned the system successfully. So we'll enter the folder. Now, after entering the folder, we have three important files in here. Data file, which has the sample input data, which is actually this kind of data, our language with the constraints. Source file, where our logic of the new language is written, Pulsar language, and the documentation file, which we have all the documentation related to the languages. So let's move to the PPT once again. So as mentioned here, when you execute this command line structure, that is Swift, then load the source of Pulsar driver. Pulsar driver actually is our entry point of our system, our Pulsar language. Then it assigns a -g, which is the goal. The goal is to load the file from the Pulsar driver into the Pulsar driver. And when the output is there, we have to eliminate it. When we compile the language .pls, it actually goes into the Pulsar driver where all the modules like SER, parser, interpreter are loaded, and then it converts the everything, every small variable into the tokens, and the token generates a parse tree. The parse tree is evaluated in the form of ASP, and then after everything is confirmed and validated, output is generated, as you can see in here. And this is done on this project structure. So let's see some sample outputs. Let's go to the terminal once again. As you can see, this is our first code. The name of the code is sample input 1, which is addition and then multiplication, as you can see. So this 10 plus 20 is assigned to value x, and then x is assigned to y into 2. So it's a one single value. So let's try to print it. So this is a single command line, which will be executing command for the sample input 1. So as you can see, the entire structure has been broken down into several keywords. First structure was print, so the keyword print is generated here, and so on. Then the parse tree generated like program to statements and statements to print, and afterwards everything is validated. We have an output. So similarly, we have also implemented various kind of assignments, break statements. As you can see here, there is a break statement. This is the combination of Java, Python, and C. We have also implemented the ternary operators as well as not operators. The not operators are from Python as well as from the Java, where is the exclamation mark is used for not equal to. And lastly, we have also implemented equality operators, which is double equal to, which compares I and 2 are they equal or not. Similarly, we will just try to live code an example through the environment to understand the language more. So we'll be coding a Fibonacci series. Make sure that your extension is .pls. So basically, what we'll do is to define the Fibonacci series. We'll initiate the variable with the variable a, which is 0, then b equal to 1. As the language is dynamically typed, and we have to terminate the whatever you have mentioned, you have to just give a colon. Then we'll initiate a third variable, that is I. Then we'll initiate a while loop to meet the conditions unless and until condition are run or not. Here n is the variable of the number, which number of the Fibonacci series we want to get, and it will be iterating and printing the statement until the condition is false. So we'll assign a plus b to c, terminate, then print c. So c is the Fibonacci series which we'll be getting in the output. Then similarly, we'll do b assigned to a, terminate, c assigned to b, terminate, and then counter +1, terminate. So let's see this code is working or not. Same. Okay, if you can see, we initiate the Swift L, which is SWR Prolog, loaded the file Pulsar driver, and initiate the goal of main, that is input, sample input Fibonacci. After the input, the automatic termination of the file will be done. So let's try to execute. So yeah, tokens have been generated, parse tree have been generated. After the validation, output has been generated. But we have not defined n, so we'll define n now. Let's example 10, terminate. So let's just, so yeah, you can see that our language is inputting, outputting some things. So yeah, the language is this, and we have successfully done the implementation. So let's move to the next slide. As I said that the scope of the language is global. So the moment you declare a variable, dynamically type variable, it is accessible throughout the code structure. Future scope is we don't have data structures at the moment, so we'll be implementing arrays and objects in our next upcoming version of the language. We also try to implement the literal syntaxes, which is the brackets and the parentheses, which will be helping in the block code because of the block scope. We also try to implement the try and catch blocks to find potential errors while coding the object-oriented programming, which will be help the developers. And at the end, we can also implement input and output structures using the modules, which will be script-based and will be loaded from third-party websites to make the language more smoother. So yeah, that's the project of Pulsar programming language. Thank you.